Hello guys, today's Leetcode problem 1443 is minimum tree to collect all apples in a tree. Minimum time to collect all apples in a tree. Okay. So given an undirected tree consists of n vertices numbered from 0 till n minus 1. Okay. So 0 is there, which has some apples in the vertices. So they in some vertices there will be apple. So you spend 1 second to walk over the edge of an tree. Okay. Return minimum time second you have to spend to collect all the apples in a tree. Starting at vertex 0 and coming back to the vertex. Okay, there is a one rule here. So we have to take all the apples in the vertices, and you have to spend 1 second to walk to the edge of the tree. So if there's a apple if there's apple here we have to if there's apple here we have to take one here one it will take 1 second to go there. Okay, we have to find minimum time second you have to spend to collect. You have to find a minimum time to spend to collect all the apples in the tree. Okay, the edges are undirected trees are given in an array. So undirected array where edge I is equal to a of I and b of I, where there exists an edge connecting the vertices a of I and b of I. So this is a parent and this is child. Additionally, there is an Boolean array has apple where has apple is true, means the vertices I has apple. So if has apple, there will be another variable given has apple. If that is true, that means that vertices or that edge has an apple. So we have to take that apple. We have to collect all the apple. We have to collect all the apple from a tree. Let's understand this question now more clearly. So here the edges are 0, 1, 0, 2, 1, 4, 1, 5, 2, 3 and 2, 6. So first vertices is 0. Then 0, 1. So this one is connected to 1. And this one is also connected 0. 0 is also connected to 2. Now 1 is connected to 4. 1 is connected to the 4. And 1 here is also connected to 5. So now 2 is also connected to 3. And 2 is also connected to 6. So this is the graph. Now what we have to see if they have apple or not. This is 0. This is 1, 2, 3, 4, 5, 6. So does 0 has apple? No. Just 1 has apple? No. Just 2 has apple? Yeah, it has apple. So we will make this as true. Does 3 has apple? No. Does 4 has apple? Yes. So we'll make this true. Does 5 has apple? 5 has apple. Does 6 has apple? No. So we got all the things 0 to 6. So now we have to solve it. So now how can we solve it? So here problem is it will take 1 second to reach to the apple. So 0 he will travel to 1 and he will check if this has any apple. 1 don't have any apple, but he is connected to 4 and 5 which has apple. So we have to travel to the 1. So this will take 1 second and 1 will travel another to the 4. It will take another second, 2 second. So total 2 second he takes. After reaching 4 he have to go again to the 1 which will take another 1 second. So this will be 3 second total. When he reaches here he have to go to the 5th apple because 5th has apple. So here he will travel here. So 3 plus 1 will be 4 second. While reaching here he have to travel again to the 1 to reach to the back parent child. So 4 plus 1 is equal to 5, which is 5. While reaching 5, then again he have to travel to 0. So 5, so 5 plus 1, another 1 second. So 6 seconds he takes to complete this full tree. To take this all apple, he will take 6 seconds. Now come like this. Does 2 has apple? Yes, 2 has apple. So another 1 second, 7 second. Does 3 have apple? No. Just 6 has apple? No. So then he have to go back to the vertices. So total it takes 8 seconds plus 1 second to go back. So the output for this equation is 3 is 8 seconds. We have 8 seconds here. Let's do it for example 2 to understand more clearly this question. Let's make a connection here. So first is 0. 0 is connected to 1 and connected to 2. 1 is connected to 4 and 1 is connected to 5 and 2 is connected to 3 and 2 is connected to 6. And like this we have to take 0, 1, 2, 3, 4, 5 and 6. Does 0 has apple? No. Does 1 has apple? No. Does 2 has any apple? No. Does 3 has any apple? No. 4 has no apple. 5 has also no apple. 6 has no apple. So there is no apple here. So this will be this will be 0. This will be 0 because there is no apple here, so it will be 0. The output will be here 0. So this is example 3. Okay. Now let's solve this question. How can we do it? First we have to do adjacent. This is a good problem. We have to solve it by how can we solve it? First we will create an array list, 2D array list. So we will create an array list of adjacent question mark array list. After creating array list, what we have to do? We have to add we have to add each list an array list here. So we first we will create an array list. After creating an array list, we will add each one has its own array list. After doing this, what we have to do here? We have to add first child. We have to add child in adjacent. After adding child, what we have to do here? See, in this problem, what we do here? After going to the child, he have to return to the parents. So what we have to add also? We have to add also the parent. So we have to add also parent. Okay. So here what I did, I traversed to the edges and first I added the child, then I added parent. So first I got the k of 0 and I added k of 1, and same thing here, I got the child and I added the parent. So we have to go to the back, right? After going to the child, he have to return back. It will take another 1 second. Then we have to use an function minimum. So we have to find the minimum number of trees, to minimum numbers of steps to collect all the apples in a tree. So now I created a function here with index 0. So starting index is 0 and adjacent will be there. We created adjacent list here. Then I did we have to check if it has apple or not. So I have also added list boolean. After that I added parent to see if it is if it is equal, then we have to skip that part. Here I initialize total as 0. Starting total will be 0 and from int k to the index of k, index of adjacent. So we have to go to the all indexes, and if the k is equal, if we have to go to the neighbors, like from here he have to go, if from 0 he have to go 1, and from 1 he have to go to the 4 and 5. So we don't want to go again to the parents, right? So that's why we skip the parent here. K, when k is equal to parent, we will skip this. And after that we have to go again, we have to use recursive code here, where the parent, where the child index will be k, and adjacent we have to add the same, and apple will be same, the both the list will be same, and index now before the index was child, now the index will be parent. So we have to traverse this array. After traversing this array, when it reaches the end, so we have to check if index is equal to 0, then no need to do it. But if index is not equal to 0, then we have to then this equation will be true. And now we have to check if this index has apple. If this index, like this we checked, if this index has apple, if it does has apple, then what we have to do? We have to return true. But for in this case, the one doesn't have an apple, but we have to go by 1. So what we did, we checked if the total is more than 0. If total is more than 0, then his children does has is plus 2. Just if the children has apple, then he have to travel here. So if total is more than 0, or thus index has apple, then it will return true. So this equation should be true and this equation should be true. Then only we will add total plus 2. After adding total plus 2, we will return total. And after recursing everything, we will return the maximum total here. And the result will be all the total. So well, let's run and see. It's running. For 7, we got 8. And for case 3, it will be 0 because all are false. So it will be 0. Let's submit. It got submitted. If you have any problem regarding this solution, if you didn't get any of the step, please do comment and I will try to help you. And if you like this video, please do like this video, and please subscribe to my channel. 1K is target. I hope you have a great day. Goodbye. Bye.